Hello everybody, welcome to Maths Unraveled. Today we are going to solve the paper for TIMO, which is Thailand International Mathematical Olympiad, and this paper came in 2022-23. This is for grade 4, which is primary 4 and year 5. The time allowed is 60 minutes for all of the questions. Let's begin. Alright, this is question number 1 of logical thinking. We have to count how many letter O's will be in the first 223 letters if we continuously repeat the word school one after another. Let me write it down in big letters so that we can see. So in one iteration of school, it has 1, 2, 3, 4, 5, 6 letters, and out of those 6 letters, we can see there are 2 O's. So for every 6 letters, we will get 2 O's. Let me write it down. All right, and we can see that the school word is repeated until we get total of 223 letters. Now, since every 6 letters, the word school will be repeated, so that means we can divide by 6 to see how many total word school are there. So division is 37, remainder 1. That means 37 iterations of the word school, and there'll be one remaining letter, which will be, the remainder 1 will be the letter S. So it does not change our iterations of O. Let's see if there are 37 times the word school is written, and each time they have 2 O's. So 37 times 2, and that gives us 74 O's. And because the last remainder did not change our O's, 74 is our answer. Question number 2. Yesterday was Thursday, so that means today is Friday. Let's start from there. Today is Friday, and we have to work out which day of the week will be 40 days later from now. All right, so in order to calculate that, we must know that every 7 days the same day comes. So after Friday, another 7 days it will be Friday, another 7 days it will be the next Friday, and so on. It will keep repeating Friday after every 7 days. So if we have to work out which day will it be after 40 days, let's put it in groups of 7. Divide by 7, which is 5, remainder 5. So that is 5 full weeks, and there's a remainder of 5. So in 5 weeks we will get to Friday, and the remaining 5 days will start from Friday, and let's see what we end up on. All right, let's write it down. So after Friday it will be Saturday, Sunday, Monday, Tuesday, and Wednesday. Let's count. So 5 full weeks, and 1, 2, 3, 4, 5. So the 5th day is a Wednesday. So our answer is Wednesday. Question number 3. There are 35 animals, including penguins and giraffes, in the zoo. The total number of legs is 94. How many giraffes are there? Let me draw a grid. All right, 2 columns, one for giraffes and one for penguins. Giraffes have 4 legs and penguins have 2 legs. Now this is a method that I work with my students. In fact, my son came up with this method, and this is an awesome method. Let me teach you. Now we are looking for total legs of 94 legs, and total animals should be 35. Now for this method, let's assume that to start with that all the animals are penguins. So let's begin from that point, and I'll keep guiding you. So if all these 35 animals go to our penguin, that means we have 35 times 2, 70 legs. Now in this method, we have to think about, we have 70 legs, but we were aiming for 94 legs. All right, so there's a difference of 24 legs that we still have. Now imagine if one animal from penguin moves over to giraffe. So effectively we gained 2 legs, because penguin has 2 legs and giraffe has 4. Let's assume one animal move. So penguins are 34 and giraffe is 1. Now let's calculate. So we effectively added 2. Let's see how. So 34 penguins is 68 legs, and one giraffe is 4 legs, so total is 72 legs, and before we had 70 legs, so we effectively added 2 legs. Now in order to actually effectively add 24, we will have to move 12 animals from penguin column to giraffe to make an effective addition of 24 legs. Oh, sorry, I deleted it. Let me write it again. So we started with 35 penguins, 70 legs. For 24 legs to be added, we move 12 animals. Let's try it. So we are just seeing the relative increase when we move from one column to another. So giraffes are 12, penguins become 23, 12 giraffes means 48 legs, and 23 penguins means 46 legs. Let's add them together, 48 and 46, that is 94. Correct, that is the number of legs we were looking for, and we got our answer. Let's read. They are asking how many giraffes are there. There are 12 giraffes. Our correct answer. Question number 4. We have to find the 10th term of this sequence, which is 3, 4, 7, 12 and 19. Now in order to find the 10th term, let's see the pattern of this sequence. Now to go from the first term 3 to 4, we can see there's an increase of 1, then 4 to 7 there is a increase of 3, and then 7 to 12 there's an increase of 5. Now we can see the increment is not constant, the increment is changing as well. Before it was 3, 5, 1, 3, 5, and following the pattern the next one is 7. So we are adding 2 to the increments every time. Let's see. So the next term would have an increment of 9. Let me change the color. So the next increment will have an increment of 9, which is 28, and the next one will have an increment of 11 following the pattern. Let's just make when will the 10th term be. So 1, 2, 3, 4, 5, 6. I have made the loops, so I'm writing the pattern for all of these numbers, and let's continue. So the ending of my number, oops, that's a very thick pen. Let me take another one. So 28 plus 11 is 39, 39 plus 13 is 52, and then adding another 15 is 67, and adding 17 it becomes 84. That is our 10th term, counting from the beginning. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our 10th term, 84. 84 is our correct answer. Question number 5. On the first day, a store sold 16 bikes. On the second day, the store sold half of the remaining bikes. And on the third day, the store sold 15 more bikes. They found that there were 7 bikes remaining at the end in the store. How many bikes did the stores have originally? Now to solve this question, some students like to work backwards, start with 7 bikes and work backward. I will show you a different method, which is a bar model, and this is a visualization technique which helps many students understand the problem and solve it as well. So let's start. On the first day they sold 16 bikes, so this is the fraction of the bar that represents the first day, and 16 bikes were sold on the first day. Now it says on the second day, half of what was remaining was sold. So the bar that is remaining, we can split it into 2 parts, and this one part was sold on the second day. Now we do not know how many bikes were sold, but we do know half of them. So that means the ending bit, the end portion, is also the same as this portion. All right, so this portion that is remaining is the same as the second day. Now it says 15 bikes were sold on the third day, and there were 7 remaining. So from the last bit, there were 2 portions on the third day and the fourth day. But now we already know that these two combined together to be the same as the second day, because a half was sold on the second day and half were remaining for the third and fourth day. So that means 15 plus 7, 22. That would have been the number that was sold on the second day. And here it is, using a bar model, we have worked it out. We have all the number of bikes sold on each day. Let's add them together using a column method, and the answer is 60. So the total bikes we had to start with is 60. This is the start of our arithmetic section, and we are on to question number 6. We have to calculate this number sentence. Let's have a closer look. 120 divided by 2 plus 120 divided by 3 plus 120 divided by 5. Now in order to calculate this, we must remember our BODMAS rule. So bracket opens first, then have precedence over all other mathematical terms, then divide, multiply, and then addition and subtraction. So we will have to do the divisions first before we can add these together. So we have 3 calculations to do before we can add them together. All right, let me remove this and work it out. So 120 divided by 2 is 60. And remember, we are not adding first. 120 divided by 3, we have to do that first, 40, and then 120 divided by 5 is 24. All right, now let's add. Now is the time to add them together. 60 plus 40 is 100, and then another 24 is 124. That is our answer, which is A. Question number 7. Find the value of this series 3 plus 5 plus 7 until 23. Now we can instantly see the terms are increasing by 2 every time until it reaches 23. Now this is a small series, and you can ask, some students can actually opt to add the numbers together, 3 plus 5 plus 7, but that's not a very effective way. In case the question gets really hard, instead of 23, they can go to any large number, and that physical method of adding up numbers will not work. So let's see this method. We have these series which starts with 3, increments of 2, and reaches 23. All right, so now this is an arithmetic sequence, and let's see how can we add them together using this method, which can be effective for small sequences as well as sequences even if they go up to 3-digit numbers or 4-digit numbers. Let's have a look. So the first term is 3, and with an increment of 2, 2, 2, 2, it goes to 23. That means, all right, so this is the rainbow method. So let's see, if I add the first and the last number, it goes 26. The same method is 5 and 21 gets 26, and if we add another bow, another rainbow, another band, that's 7 plus 19, that's 26 too. So we can see the whole series is actually divided into pairs of 26. Now what is remaining for us is to find out how many bands of or pairs can we make from this series. So to find that, we should know the number of terms that are in this sequence. Now you can actually, of course, go 3, 5, 7 and find out how many, but again, just like I said, it's not effective. We can say we started with 3, went up to 23. That means we effectively went up by 20, and this happened with a jump of 2 each time, with addition of 2 each time. So let's see how many groups of 2s did we need. We needed 10 jumps or 10 increments of 2s to reach 23. So the number of terms that we have, don't get confused, this is not 10 jumps were required, but we also have the first term to count for. So the number of terms we have is number of jumps plus 1, which is 11. So there are total 11 terms. So that means our pairs are actually 11 divided by 2, because every pair requires 2, and if you remember, 11 is an odd number, so that means there will be a number which will just amount to half a pair. If it was even number, we will have full pairs, but because we have an odd number, we have to divide it by 2. So let's calculate. It is 143. We found our answer, 143. We are on to question number 8. There is a number sentence for us, 123 times 53 minus take away 123 times 12. Now there's a series of operations, but again, looking at the BODMAS rule, we have to think of multiplying or dividing first before we can add or subtract. So these are the 3 calculations that we have to solve first, but noticing something that we have 123 common in all those terms. And don't go for actually multiplying 3-digit number by 2-digit numbers. We can see that there's 123 in each of them, so I can easily take out 123 common from all these multiplications. So from the first multiplication, we can see if I pull out 123 out, we just have 53 remaining inside. We are not changing the calculations, we are just writing it another way to make our work easier. Take away from the second term 123 out, that means it's only 12, and the next one is 59. If we were to open the bracket at this time, we will get our same calculation that we started with. So we have 123 here, and we can solve this. 53 take away 12 plus 59, I can add 53 and 59, that is 112. Take away 12, which actually seems quite easy now, because 112 times my take away 12 will be 100, and that is a super duper easy calculation. It is 12300, 12,300, which is our answer, B. Question number 9. Find the value of this series, and we can see the signs are alternating: 48 minus 46, 44 minus 42, and so on. And the whole numbers itself, they are decreasing in twos. So we started with 48, the next one is 46, 44, 42. This is a arithmetic sequence, but not exactly, because each time the operation is changing. But we can look 48 minus 46, if you look at that pair, that's 2. Now the next 2 terms, if we put them together, 44 take away 42 is again 2. So actually, if we combine the whole series in pairs of 2s, every 2 terms is yielding 2. Now the only thing remaining is to understand, they will all give 2, is to how many 2s are there. Now don't go physically counting how many 2s are there till 48. We have to work it out with logic and with reasoning, so that even if they go to a difficult number or difficult question, we can still work it out. Now again, we have used this method in the previous question, and we'll do it again. We started with 48, we deducted 2 every time we went to the next term, and we reached a 2. So that means we had a deduction of 46, and those were in groups of 2s. So we divide by 2s, that means there were 23 jumps, or 23 decreases starting from 48 to reach a 2. Now number of terms, as we said before, number of terms is always the number of jumps or number of gaps plus 1. So 23 plus 1 is 24, and we had the answer 2 for each pair. So 24 terms divided into pairs is, let me remove all that. So 24 terms divided into pairs of 2s to have the answer 2 is 12 pairs, and each pair is the answer 2. So that means our final answer is 2 plus 2 plus 2, 12 times, which is 12 pairs, and that means our answer is 12 times 2 is 24. Easy peasy. We are on to question number 10 of the arithmetic section. There's a calculation given, a column addition. A, B, C are all different digits, and we have to work out what is the value of C. Now there are 3 missing digits, A, B, and C. There are variables. There's an addition given, but we have to look at where should we start from. Now, looking closely, this is the point at the hundreds column that we must look closer to understand. Now we can see we have an A and there's nothing in the column below, and it also gives the answer 1. Now remember, A cannot be 0 because if it's a 0, it's a 2-digit number. So the minimum value of A is 1 and the answer after addition stays 1 too. That means A must actually be 1. So we already worked out the value of 1, being clever, looking at the hundreds column first. So A is 1. Let me write it down. And now, all right, the tens column looks the next best place to start with. B and B gives 4. They're the same digits, same number, added twice to make 4. That is easy. We can have 2 and 2. So the B must be 2 to give the answer 4. And now looking at the units place. So we already know B is 2. What should we add to it to get a 5, which is 3? So we found our answer for C. C is 3. And now just to make sure that our calculations are correct, we are writing that down. ABC is 123, adding 22, which was BB. Let's work it out. 3 plus 2 is 5, 2 plus 2 is 4, and 1, which is the exactly same as in the question. So the question asked us to find C, which is 3. Here is our answer. Alright, so this is the beginning of our number theory, and we are on to question number 11. Find the smallest 4-digit number which can be divisible by 9 and all the digits are different. So there is a condition that we have to remember. Now remembering the divisibility rule for 9 is all the digits must add to be a number which is a multiple of 9. So it can be 9, 18, 27, 36, 45. All the digits must add to a number which is multiple of 9. And this applies to 3, 4, 5, 6, 10-digit numbers. It applies to all. Now instead of working out the answer, there are 4 answers given. So we can actually apply the rule and see which answer works in our favor. So let's look closely at the answers. Number A, 1008. Now 1 plus 0 plus 8 is 9. So this number is divisible by 9, but there are 2 zeros and one of the condition was the digits are different, so it does not match our condition, so this cannot be our answer. Let's look at B. 1 plus 0 plus 2 plus 6 is again a 9, so that means this number is divisible by 9 and this can be one of our probable answers. Let's look at C. 1 plus 0 plus 1 plus 7 is again a 9. So this number is divisible by 9, but I can see there is a 1 and a 1 repeated again. Digits are not different, so this cannot be our probable answer. Let's look at D. 1 plus 0 plus 3 plus 5 is again a 9, so this number is divisible by 9 and it's following all the rules. So we have 2 choices, but because we have to find the smallest 4-digit number and the smaller one out of these 2 is 1026, the smallest number. We are looking for the smaller one, so this is the option that we'll go with, and answer is 1026. Question number 12. Now this is a very interesting question, and TIMO, and I've seen this type of questions in a lot of Olympiads, so understand the method. It's a very easy method, but we need to understand how it proceeds. So let's have a look. So we have to find the last digit. We are only interested in last digit of this multiplication. 3 times 3 times 3, which is 2023 times, which is effectively 3 raised to the power 2023, and we are only focused on the last digit. So there should be a pattern somewhere. Let's try to work it out. So let's start with the first digit. So 3 raised to power 1, which is only first 3, is 3. So the first place is 3. 3 raised to power 2 is 3 times 3, which is 9. All right, now let's 3 times 3 times 3 times 3, 3 cube is 27. All right, 3 raised to power 4, which is 3 times 3 times 3 times 3 is 27 times 3. Let me get the pen. 27 times 3 is 81. All right, now we don't need to focus on the tens place, we are just focusing on the ones place. Let's go to 3 raised to power 5. 81 times 3, because we are multiplying another one, is 243. Now from now on I'm not going to focus so much on the first hundreds, tens or thousands digit. We are just going to focus on the ones place. So now we can see we are back to, we had 3971 and now we are back to 3, which seems like a pattern is developing, but just to make sure, we will continue the series and see if it's actually the case. So 3 raised to power 5 is back to 3. Let's go to 3 raised to power 6 and let's work out this answer. And again, because I'm not worried about the other all digits, but let's try to do it. So I'm not worried about other digits, but the ones place is 3 times 3, which will be 9. So it will have hundreds and tens place, but we are just not working on that. So it went back to 9, and 3 raised to power 7. 9 times 3 is 27. So the last place, ones place, is 7. And 3 raised to power 8 will have 7 times 3, 21. So the ones place will be 1 again. And as we can see, the pattern is repeated again. 3, 9, 7, 1. All right, so every fourth power, the pattern is repeating. So now let me remove all this so that we have clear space. So we are looking for 3 raised to power 2023. So that means 3 is multiplied 2023 times, and we have already seen with every fourth power the pattern repeats. So let's divide our 2023 into groups of 3, because we are just focused on the last digit and we already have a pattern. Let's try to put it in groups of 4. So 2023 divided by 4, let's work it out. 4 times 5 is 20. 0, carry over 2, 23. 4 times 5 is 20, remainder 3. So there are 505 iterations of this pattern, 3971, and there's a remainder 3. So 505 full pattern repetitions and remainder 3, which will be, let me write it down, 397, because the pattern repeats from there. So the 3 remaining terms, the last terms will be 3, 9, and 7. So that means our series will end on a 7. So this will be the number that we'll end with. So the answer for 12th question is 7. Question number 13. Now this is a special symbol that the question has defined. A, the special symbol, B, and this is the definition. This is how they process the special symbol. Let's have a closer look, and we have to find the value of A. 8, special operation 6. So the A is 8, B is 6. Let's work it out. All right, so 8 with the special symbol with the special operation 6 is 8 times 5, which is 8 times 5. Take away 10. I'm just putting the values in the formula, times A, which is 8 divided by 2, plus B, which is 6. All right, let's work it out. 8 times 5 is, remember we have to apply the BODMAS rules, so that means we have to always use multiplication and division before we can add and subtract, and we have to, the precedence is always for bracket opens, then division, multiplication, and then addition, subtraction. 8 times 5 is 40, take away 10, times 8 divided by 2 is 4, plus 6. All right, let's work it out. That's 30 times 4 plus 6 is 10, which is 30 times 10 is 300. We found our answer, which is C. C is our answer for this question. Question number 14, the sum of A and B is 42, and we also know that A is 5 times of B. Let me write it down. A and B together, they are 42. A plus B is 42. And now, as it is given that A is 5 times of B, so instead of A, I can actually write 5B, and that changes my whole equation into just one variable. 5B and another B makes 42, which means 6B is 42, and I can divide both sides by 6, which will mean that B, 6 and 6 cancels out, B is 42 divided by 6, which is 7. I found the value of 7. I found the value of B, which is 7, but the question is asking for the value of A. It's easy. I can substitute the value of B in the first equation. A plus B is 42, which will mean, let me write it down, A plus 7 is 42. We can take away 7 from both sides. 7 and 7 will cancel from the left side, so A equals to 42, take away 7 is 35. We found our answer for A, and the answer is D. Question number 15. Now this is an interesting question. If a 6-digit number 20233A, we don't know the value of A, for this number is divisible by 3 but is not divisible by 2, what is the value of A? Now in order to find the value of B, find the value of A, we must think about the divisibility rule for 3. As we know, for any number to be divisible by 3, the sum of all the digits must be a multiple of 3. It should be able to divide by 3. So all these numbers, let's add 2 plus 0 plus 2 plus 3 plus 3. So these are the ones that we know already. So that is 6 plus 4 is 10. So we have 10 already, and A will add to its value. Now all the multiples of 3 which are bigger than 10 are 12, 15 and 18. Let's try to work them together. So if we are looking for a sum of 12, we already have a 10 from the first 5 digits. If we are aiming for a sum of 12, that means A. If we are aiming for a sum of 12, that means A must be 2. If we are aiming for a sum of 15, that means 10 plus 5 is 15. That means A must be 5. And if we are aiming for 18, that means A must be 8. We have 3 options. But now looking at the second condition, our number should not be divisible by 2. If it's not divisible by 2, that means our number is odd. So that means the ones placed must be a odd number, 1, 3, 5, 7, 9. Now look at that condition. So that means A cannot be 2. This will make it an even number. So A is gone, A cannot be 2. Similarly, A cannot be 8 because that will turn the whole number into an even number. So the only option that we have is A is 5. Question number 16, and this is, we are starting our geometry section for this paper. Question number 16. How many rectangles in the figure containing the candy are there? Now you can physically actually draw the squares and rectangles around the candy and count the numbers, but there is a trick to solving these kind of questions, and these kind of questions appear in a lot of Olympiad exams and competitions, so it's a good idea to learn and understand this. So we are looking for a rectangle or square which has 4 sides. So we are going to look at options for all 4 sides that are available in the given question. And that will give us the number of rectangles that can be there. Let's have a closer look. So we are looking for possibilities for the 4 sides. Look at the top side. This side, if we try to do on the grid given above, what are the possibilities for the top side? Let's have a closer look. So I can put the top side here, or the second option can be, let me try to grab a line if that works better. Okay, it's taking too much time. So I have only 2 options for the top edge. So let me write, there are 2 options for the top edge. Now let's have a look on the right edge. So how many options are there for my right edge of the rectangle? So looking at the grid again, I'm not going to go for line, just a little wavy lines is okay. 1, 2, and 3. There are actually 3 options where I can have my right edge. All right, writing. All right, so there are 3 options for the right edge. Now looking at the bottom edge, how many options do we have for this? Looking at the grid again, 1, 2, and 3. There are again 3 options for the bottom edge, and this will make sure the candy is enclosed in all the rectangles that we are choosing. So there are 3 options, and now let me choose a different color. I should have actually chosen a different color for each. The left edge, let's try to draw it in the grid. There's one here, option 1 and option 2. There are only 2 options because if we go any further we will remove the candy from our grid. So these are the options for 4 sides, 4 edges of our rectangle: 2, 3, 3, and 2. And the total number of rectangles is 2 times 3 is 6, 2 times 3 is 6, which is 36. So there are 36 such rectangles which will still have the candy inside them. Our answer is B. Question number 17. The figure below is a big square with side length of 12 centimeter formed by 4 identical rectangles. So we can see this is our big square and it has 4 identical rectangles, which are first, second, and we have the third rectangle here and the fourth here. They are all identical, and there is a small square, one small square which is colored green right in the middle. The area of the small square is 36 centimeter squares, and we have to find the area of the find the area of each rectangle. So we have to find this area that in the question. Let's have a closer look. Let me remove this so that we can work it out. So looking at the square in the center, it has area of 36 centimeter square. So finding the length of it, the area of square is length times length. So we are looking for a number that when it is multiplied with itself, it will give 36. Yes, you're correct. That number is 6 centimeters. So each side of the square is 6 centimeter, and that will give us the area of 36 centimeters square. Now we know the side is 12 centimeter, but we already know this part, this chunk of the whole length is 6 already. And looking at, because these are all identical rectangles, so the bottom part which is remaining and the top part are exactly the same because they're identical rectangles. So 12 take away 6 is 6, so this 6 is coming from top and bottom bit. So 6 divided by 2 is 3. So that means each of these sections of the edge must be 3 centimeters long. Now again, looking at our rectangle, we can see that it is 6 and 3, 9 centimeter. We can see that what square is 6, and then another 3 is from the width of the rectangle is 9, and the width of the rectangle is 3. So that means the area of our rectangle that we were looking for is length times width. So area of the rectangle, each rectangle, they are all identical, is 9 times 3 is 27 centimeter square, and the answer is A. Here is our answer. Question number 18. The area of the rectangle is 30. If the sides of the rectangle are natural numbers, they cannot have fractions or decimals. Find the minimum value of its perimeter. We are looking for a small value of perimeter with area equals to 30. Now the area is length times width or length times breadth. Let me draw a table so that we can explore the different possibilities. So we are looking for the area of 30, and we want the perimeter to be as low as possible. Now to find the area 30, the first option is 30 and 1. That will give us the multiplication. 30 times 1 is 30, and the perimeter in this scenario is length times 2 plus width times 2, there are 4 sides in a rectangle, so 30 plus 30 is 60, and 1 times 2 is 2, 62, which is quite large. But let's think about other possibilities. To have an area of 30, we can have 15 and 2. Those are the other two factors. So side length of 15 and 2, and this time the perimeter will be 15 times 2 is 30 plus 2 times 2 is 4. So the perimeter is 34, which is significantly lower than 62. But let's keep exploring. Again, looking at the area of 30, another factors are 6 and 5. 6 times 5 is 30, and the perimeter in this scenario is 6 times 2 is 12, and 5 times 2 is 10, and the total is 22, which is lower than both the above values that we got, 62 and then 34, and now is 22. Now let's see if there are more possibilities for area 30. Now other factors, we don't have any more factors, but we can switch them around, 5 and 6, but that effectively means the same thing. We are just changing the column, which is length and breadth, but we are ending up with the same rectangle. So we have already found our smallest perimeter, which is 22. Answer is D. Question number 19. At least how many small squares can be seen if viewing the figure from the front? So we have this arrangement of cubes, and we are looking from the front. This view is a slightly from the top. So if we are looking from the front, how many squares can we see? So let's try to think about the visualization. If I look from here, I will definitely see these two squares. They are right in the front, but the block below will be hidden. The 2 blocks behind them will be hidden, and what I will be able to see behind them is the top one. Alright, so this is the square that would still be visible from the front. Now looking at the second column, this will be visible. This is not hidden by any of the other blocks. And looking at the other one, we can see the first square, but all the other blocks will be hidden behind it. Now looking at the last row, these two will be visible, but nothing else. So let's count them together. 1, 2, 3, 4, 5, 6, 7. There are 7 squares which are visible to us. A is our answer. 20th, the last question of the geometry section. Andy draws and paints 2022 in his grid paper as shown below. You have to find the area of the painted area in centimeter square. Each of these little squares on the grid is 1 centimeter each. All right, now this is an easy number actually if you look at it, because the 2 is repeated 3 times, so we can just find the area of one of these 2's and multiply it by 3, and then find the area of the 0, and then our job will be done. So let's have a closer look at this 2 to find out the area. Now, as given in the question, each of these little squares on the grid is 1 centimeter each. So if a number occupies the whole square, the area is 1 centimeter square. So we are finding the number of fully colored squares. So this is 1, 2, 3, and there's one on the top. So there are 4 completely filled squares in the number 2. Let me write it down. And now we have to focus on the other which are remaining. If we look closely, these halves, these are exactly half of the squares cut by the diagonal. So this half can actually be adjusted with this half, and together they can make 1 full square, 1 full centimeter square. So I can count these 2 as 1 square, 1 centimeter square. Similarly, I can count these 2 as another square, and these 2 as another square. So I have 6 more halves, or 3 more full squares. So that the area of 2 is 7 centimeters square. Zooming out, if the area of this 2 is 7, so is the area of this and this 2. Let's work on this 0. Let's count the number of squares, and this is easy peasy because they are all full squares. 1, 2, 3, 4, 5. They are full squares. 6, 7, 8, 9, and 10. There are 10 full squares. So their area is 10 centimeters square. We need to just add the areas of all the individual areas of 2022. 7 times 3, there are 3 groups of 7 and another 10, which is 21 plus 10. So this is 31 centimeters square. So the area of the painted is 31 centimeters square, which is C. This is the new section starting now, combinatorics, and this is question number 21. How many two-digit numbers with the difference in the digits being 3? So how many two-digit numbers are there in which the two digits differ by 3? Let's write them down and count them together. So in order to work that, let's start with the biggest digit in the tens place. Let's have a 9. So in order to have a difference of 3, we can't go higher, but the difference of 3 will make it 6. 96 is a possibility, and we can reverse the digit, of course, so there is a possibility for 69. Let's start with 8. Again, to make a difference of 3, we can start with 85. 85, and the reverse 58 is possible as well. Again, starting with 7, we can have 4 or 47. Now starting with 6, again we can go with 3 to maintain a difference of 3, 63 or 36. Let's go to the next column and start with 5 to again have a difference of 3, so 52. And also 25. And now we can go to 4. Now there you could have gone higher as well, 47, but that's already calculated, so we'll go to 41 and 14, and then 30. Again, going higher, we have already calculated 36 and 63 before, so we don't need to go for 6s, we have to go below, so that's 30. But remember, in this one the reverse is, let's look at what is the reverse. Reverse is 03, which is actually not a two-digit number, so 03 is not possible. So to calculate how many two-digit, and these are all the numbers which have a difference of 3. Now let's calculate them. So instead of counting one by one, we can see how many pairs are there. 1 2 3 4 5 6 pairs, that is 12 numbers, and also 30, which is just one more because no reversal. 13. Our answer is C. Question number 22. In a box there are 7 blue balls, 5 red balls and 6 black balls. Anna takes out some balls without looking into the box, so completely random. At least how many balls should Anna take out to make sure that she gets 2 balls with different colors? Now, in order to solve questions like these, we have to assume the worst possible case scenario. Best possible case scenario would be she pulls out 2 balls and they both are actually different colors. That would be the best possible scenario, but that does not guarantee that every time you pull out 2 balls they are of different colors. So we have to think of the worst possible case scenario in case everything is going wrong, but these many balls can still be pulled out, so that it's 100% sure, guaranteed that 2 of them are at least different colors. So in the worst case scenario, which ball should we look at? Blue, red or black? 7 has blue balls. Again, looking at worst case scenario, we will look at 7. So if we pull out 7 balls, they can all, if we pull out 7 balls, they can actually all be just blue. There's no guarantee that they will be 2 colors. They can all be just blue. But if we go to 8 balls, the 8th ball has to come from either red or black balls, because all the blue balls are finished. So if for the 8th ball it is necessary, it will be either red or blue. Does not matter which color comes out, but in our combination we will have 2 different colors. So always remember, in these type of questions you're looking for the worst case scenario. So for this answer we have 8. If we pull out 8 balls, it is guaranteed that there will be at least 2 colors. So our answer is 8, which is C. Question number 23. How many two-digit numbers are there which are divisible by 4? Now, don't go ahead and count all them by counting in fours. We have a method because easily the question could have been difficult in P5, P6. They might ask 3-digit numbers or 4-digit numbers or 5-digit number, and physically calculating how many numbers are there in counting in fours is not possible. So let's work out a method. Now let's start counting in fours. So 4, 8, those are still single digit numbers, and goes on, but I still haven't received, so let me 12. That's the first two-digit number while counting in fours. And because we are looking for two-digit numbers, so the highest two-digit number is still in fours. I don't have to worry about all the other numbers. The highest number is 96. Now you could go 12, 16, 20 and count them, but again, just like said, the questions will get difficult, so it's better to understand a method. 12, and then each time you're adding a 4 and we reach 96. So we are adding 4s every time, and to calculate the number of terms in this sequence, so we ended with 96 and we started with 12, so that means we gained 84. We gained 84, and this is with each jump of 4. We added 4 each time and we got 84. So that means how many jumps were there? That is 21 jumps. There were 21 increments from 12 to reach 96. But how many terms were there? Always, just like I said in the question before, number of terms is number of increments or decrements and plus 1, number of jumps plus 1, because we always have to take in consideration the first term. So it's 21 plus 1 is 22, which is our answer. There are 22 two-digit numbers which are multiple of 4. Question number 24. A flight of stairs. Now this is a very interesting question, and one of the questions, like this type of questions, I've seen in many competitions in Olympiads, and this can be very tricky if you don't follow the method. So today I'm going to teach you the method in detail, so make sure you make good notes of it and pause the video and try to do it by yourself and repeat it again if you don't understand it. All right, this is a very visual method and each step is explained very clearly. A flight of stairs has 9 steps. I've drawn these 9 steps here to represent the 9 stairs, 9 stair steps. Daisy can go up 1 step or 2 steps at a time. The 5th step cannot be stepped on, so let me just cross out the 5th step that she cannot step on. So this is very visual, just like I said, you're going to see each step. How many ways are there for Daisy to go up the stairs and reach the final step? So starting from the beginning, she has so many ways. She can skip all the way, or 1 step, 2 step, 1 1 1 2 2 2. There are many ways for her to reach the last step. So how do I calculate how many exact steps are there? How many different ways are there for her to reach the last step? So let's see. This is our Daisy standing here. Hi Daisy. All right, so how many ways are for Daisy to reach the first step? And of course there's only one way. She has to just step on the first step. There's one way. All right, let's look for how many ways are there for her to reach the next step. Now she can of course come from the first step, take another step and reach the second step, but there is also another possibility that where she's standing outside, she can just take 2 steps and jump directly to this second step. That's another possibility. So in total, she has 2 different ways to reach the second step. Now let's have a look at the 3rd step. So for the 3rd step, how many ways can she reach here? Now she can reach from the step before. She can take another step. So there are 2 ways to reach. There were 2 ways to reach step number 2. So there are 2 ways to reach to the step number 3 from this step. But there's another possibility. She starts from the step before and take 2 steps ahead from there and reaches the 3rd step. So in total, she has 3 different ways, 2 plus 1, to reach the 3rd step. Now let's look at the 4th step. Again, for here, she can take 1 step from the step before, or she can actually jump 2 steps from step number 2. So that will be another way. So she can come from here. So the total number of ways for her to reach step number 4 is 3 plus 2 is 5. Now she cannot move on to step number 5 because it's destroyed. So she has to go to step number 6, and the only way for her is to reach from 4th step, jump 2 steps from the 4th step and reach directly to step number 6. Now there were 5 ways to reach step number 4, so they are the same ways. There are no more ways, they have not increased. 5 ways to reach step number 6. Now to reach step number, because step number 5 was not available, step number 6, of course, again she can only reach from here. There is no possibility for her to take 2 steps from the destroyed step, so this is not available. So still for step number 7 she still has 5 ways to reach step number 7. Now look at step number 8. Again she can reach from the step before, 5 ways to reach from there, or she can reach step number 6 and jump. So there are 10 total ways to reach step number 8. Step number 9, again she can jump from the step before or take 2 steps from the step before that. So that's 10 plus 5 is 15. So there are 15 different ways for Daisy to reach step number 9. And this is our answer, C. Question number 25. This is again a question like 24 where we have to find different ways. Thomas wants to go to school, but he can only move up or right along the road on the map below. How many ways are there for Thomas to go to school? So Thomas is standing on the bottom left and he has to reach the top right. How many ways are for him to reach? Now remember, there are multiple ways for Thomas to reach there. He can take any of these paths, go up and right, this way, that way, and we have to find out exactly how many ways are there for him to reach. He can take many twists and turns to reach his goal. So let's find it out in a systematic way. Now this is a question that again comes in P6, P7, and this P4, P5, P6, and in many competitions. So let's learn this easy method, a step-by-step method. So he starts from here, from this point. How many ways are for him to reach this point? There is exactly just one way. He can start from the beginning and reach here. Similarly, to reach this point, he has exactly one way, and continuing this to reach this point, because he can just move right, he has only one way. Right, to reach the end point, he has again just one way to reach the end too. And to the top, so we have covered all the edges next to him. There's just one way. Now looking at this point, now this is interesting. How many ways to reach here? He can go up from here, or he can go right from here. So there are 2 paths, 2 ways for him to reach this point. That is interesting. And to reach the next point, again he can move up from here, or he can go right from this point. So that means 2 plus 1, he has 3 ways to reach this point. Now looking at this point again, he can actually just move up. There is no right from where he can come, so he has to take the point below and just move up from there. So there are exactly 3 ways. There is no increment in the number of ways. 3 ways to reach this point, and to the top again 3 points. And for this point he can come right as well, so 3 plus 1 is 4. So he can reach this point in 4 different ways. Now looking at this point, he can come right, only there is no way for him to come up. So there's 3. Looking at the point above, so there's 3 ways for him to come from down below, and 3 ways for him to come from the right side, so that's 6. Looking at the point above, he has 4 ways to come from the right side, and 6 ways to come from the point below, so that's total of 10 ways. And looking at these points now, 3 and 1, so that gives a total of 4 ways to reach this point. This point is 6 plus 4 is 10. And finally, to reach his school, he can come from this path, from right or top. So he has 10 plus 10, 20 different ways to reach his school from where he was standing going only in right and up directions. This is the end of our question paper, question number 25. I hope you liked the methods that I showed you. If there is any confusion, do mention in the comments. If you learned something new today, do let me know so that I can continue to make videos that can help other students as well. Do like and subscribe my channel. Do share it with any of your friends who is also preparing for mathematics competitions and you think this video can help them. All right, all the best for your exam. I hope you fly with passing colors. Do come back. I'll keep uploading new videos. If you have any question or any particular paper that you want me to solve, do let me know and I'll find time to upload the answers to that paper. All right, take care, all the best, keep doing maths. Bye bye.